This is the circuit that operates a kicking device on a soccer robot. The kicker itself is a solenoid shown here in the circuit. The solenoid kicks when a sudden burst of current flows into it. This happens when the capacitor is allowed to suddenly discharge into the kicker by closing this switch. When this switch closes, there is a sudden build-up of a magnetic field in the solenoid. This causes the solenoid to generate a huge induced voltage, which, if unchecked, would burn out the contacts of the switch with just a few operations. To prevent this, a suppression diode is put in parallel with the capacitor, so the induced current, instead of flowing back into the rest of the equipment, flows harmlessly around this loop. At the end of the kick, the relay switch reconnects to the power supply and the capacitor recharges. The resistor R is needed to prevent the charging current from exceeding the current rating of the relay contacts. However, this resistor must also be small enough to allow the capacitor to discharge in around 1/10 of a second to make the kick strong enough. We organise this by making sure that the time constant, T equals C times R, works out to about 0.1 seconds. The voltage doubler is used because the energy stored in a capacitor is proportional to the square of the voltage. So by doubling the voltage, we can get 4 more times the energy stored in the capacitor, which makes the kick more powerful. The relay is activated by one of the output pins on the microcontroller via this NPN transistor.